Let's see how we can predict spontaneity for reactions. If you have a reaction that has a negative delta H and a positive delta S, okay, let's look at what happens. If delta H is negative and delta S is positive, what's a negative number minus a temperature, which is always positive, times a positive number? Negative minus positive is always going to be negative. So if you have a reaction that is exothermic, okay, with a positive delta S, it will always be spontaneous. What happens if it's the other way around? If you have an endothermic reaction, okay, delta H is positive, and delta S happens to be negative, it's the opposite, then delta G in that case will be positive. That reaction will be always non-spontaneous. Okay? Now, what about negative and negative? This is exothermic again. Okay, this one was endo. This is exothermic, but the entropy decreases. These are processes that tend to be spontaneous at lower temperature. Why is that? Let's look at our expression. Delta H minus T delta S, right? If delta H is negative and delta S happens to be negative, what did we say a negative delta H is? If you recall, a negative delta H is good, right? Why is negative delta H good? Because that gives heat to the surroundings. It makes the entropy of the surroundings go up. Okay? A negative delta S is bad, right? Why is it bad? Because you want the entropy of the universe to increase. You don't want, as much as possible, you don't want entropy to go down. But if the entropy of the system has to go down, we say your system is incurring an entropy debt to the universe. It has to make the entropy of the surroundings go up. Okay, that is why in this second case right here, if the entropy goes down, okay, you have to dump heat to the surroundings for the entropy of the universe to go up. But if you're absorbing heat from the surroundings, so these are two bad things. This is bad and bad, okay? So this is bad. You don't want entropy to go down, right? This is bad. You don't want entropy to go down. And exothermic is good. Okay, why is exothermic good? Because you're dumping heat to the surroundings, you're making the entropy of the surroundings go up. So that's good, that's good. So this is always spontaneous. This is bad. Two bads means won't happen, right? Always non-spontaneous. Exothermic is good, but if the entropy goes down as a result, what happens? You have to balance the good and the bad, right? So what happens at high temperature? Higher temperature favors the bad, right? So that means it's more likely to be spontaneous at low temperature. What happens if this thing goes to zero? Then it's just going to be good. The rest of it is good, right? So these are more spontaneous at lower temperature. So like turning from a gas, an example of this would be, what did I just do? Press the wrong button. Turning from a gas to a liquid. Gas to liquid. Okay, what happened here? Okay. Gas to liquid. What's the delta S for that? Positive or negative? Negative, right? That's negative entropy. Why? More freedom of movement in the gas, more restricted motion in the liquid. You say there's more order in the liquid, more disorder in the gas. So that's bad, right? To mitigate that, you lower the temperature because delta G is equal to delta H minus T delta S. So you minimize the effect of the bad by going to lower temperature. So condensation happens better at lower temperature than it does at higher temperature. Liquid to solid, same thing. Freezing is favored at low temperature, not at higher temperature, right? So that's why uh, it snows in the winter. When the temperature is colder, liquid water turns to ice. It doesn't snow in the summer. Okay. Now, if delta S is positive, then that's good. But if delta H is positive, then that's bad. Okay. An example of this would be going from solid to liquid. Solid to liquid, that's an increase of entropy, right? But that doesn't mean it's going to be spontaneous, because why? Melting of ice, it's not always going to be spontaneous, right? It's spontaneous when you're in a hot environment, right? But if you put your ice in the very cold freezer, it's not going to melt spontaneously, right? So it's favored at higher temperature. Okay, what's the delta S for melting? It's positive, right? You go from solid to liquid. Your molecules need to absorb heat in order to free themselves from the forces of attraction that are holding them together. But at the same time, the entropy increases, okay? But at the same time, they're drawing heat from the surroundings. They're causing the entropy of the surroundings to go down. Okay, so you have to kind of balance two things. Let's look at this reaction here. Combustion of sugar. If sugar is burned, okay, do you think this reaction is going to be always spontaneous, always non-spontaneous? This will be spontaneous at higher temperature or spontaneous at lower temperature? Okay. Let me help you out here. What delta H do you think is this going to be? When sugar is burned, does it generate heat or absorb heat? When you burn something. So what's delta H? Negative. Is that good or bad? Good, because that gives that gives heat to the surroundings. That increases the entropy of the surroundings. What's your delta S here? Look at the complexity of your molecules. Okay, positive or negative? So let's see. Is this going to be always spontaneous, always non-spontaneous? Spontaneous at a higher temperature, spontaneous at a lower temperature. Correct answer. It's always spontaneous, right? Delta S is positive, right? Simpler molecules here. So increase entropy, increase disorder. So delta H, positive entropy is good, right? So it's going to be always spontaneous. Now you may be asking, why doesn't, this is sugar, why doesn't sugar in your spoon, just take a spoon of sugar, why doesn't it just burn by itself? So it's always spontaneous. Reactions require an activation energy. Once you get it going, then it will be spontaneous. Okay. Some reactions do require a little activation for them just to get started. But once they get started, the process is spontaneous. And like I said, spontaneity and how fast things happen is different. It's different from how fast things happen. Okay. So things that are slow have a high activation energy. If you give them enough activation energy, then you can get them going. Decomposition reactions are generally endothermic. Okay, why is that? Let's look at the example here. Barium chloride dihydrate. If you want to decompose this, you're going to have to apply heat to this. So this is an endothermic process. So delta H here would be positive. Now, when you're decomposing, what's your delta S? So delta H is positive. Is that good or bad? As far as spontaneity is concerned. That's bad, right? Remember, delta H minus T delta S. You want that to be negative. So if that's positive, that's bad. What's delta S for this? Positive? Why? going from this to this, simpler. If you're going to simpler molecules, you're looking at a positive delta S. So that's good, right? How do you emphasize the good over the bad? Ready? And when we say good or bad, it's just, I'm not making any moral judgments there, okay? It's just about whether it's good for spontaneity or not. So this is going to be spontaneous at higher temperature.